In today's episode, Kendra Dodson tells us about SD-WAN technology.
Hey, we know what happens. We know how to fix it.
Hunts overflow encounters.
We've got definitely customers, I think, with upwards of like 15,000 routers.
And packet over-fragmentation.
Like, okay, obviously something here happened. Now it's just figuring out what.
Welcome to Cisco Tech Stories, a podcast with real-life stories from real-life engineers. Your hosts are Nicholas and Tristan.
Welcome back to Cisco Tech Stories. In episode 26, we're diving deep into the world of SD-WAN with a very special guest. Joining us today is Kendra Dodson, an experienced SD-WAN technical leader in the Cisco CX department. Kendra brings a wealth of knowledge and hands-on experience in helping customers transform their networks with SD-WAN technology.
That's right, Nico. Kendra will walk us through 3 fascinating SD-WAN use cases, and her insight into SD-WAN architecture, deployment strategies, and real-world stories make this episode a must-listen for anyone who's interested in the future of networking.
So whether you're a network engineer, an IT leader, or just curious about SD-WAN, stay tuned as we unpack the latest trends and stories with Kendra Dodson here on Cisco Tech Stories.
Let's get started.
And hello, Kendra.
Hi,
Hi.
Kendra.
Can you introduce yourself for us?
Hi, so I'm Kendra Dodson, and I'm a technical leader in the SD-WAN space. I've been working for Cisco since 2016, and I actually started in the service provider space. So I spent about a year there right out of college. And then we acquired a company called Viptela, which most of you know has become our SD-WAN solution. From there, my manager at the time knew I wasn't particularly happy in the SP space it was a different space in SP. It was all software support. So supporting NSO and WAY and products like that really help service providers manage their network. So it wasn't a lot of what you think of when you say, I want to go be a network engineer at Cisco. It wasn't what I was like, this is not what I signed up for.
Right. So very management oriented, right? Automation and all that stuff.
Exactly. It just wasn't what I wanted to do. And my manager knew about that. And he's like, hey, they're actually looking for people. We just acquired this company. You want to move over. And funnily enough, we actually use NSO inside of vManage, which is one of the SD-WAN controllers. So he also thought, hey, there could be some overlap. So they sent me to training and all that, and I moved over, and kind of the rest is history. I've spent the rest of my time at Cisco so far in the SD-WAN space, and grew really from, like, when I joined the team in RTP, I was the third engineer to join the team. There was a very small support team at that time. And then to be able to help build and grow the team into what it is today has been really amazing.
Talking about overlap, I've seen some people coming from the VPN side. Like, we had a VPN team, and that kind of became the SD-WAN team, which was funny because it was security oriented, and now boom, it's an enterprise, you have SD-WAN. But you came from service provider, and I guess there's both, right? Because you need, I mean, it's WAN, but it's also secure, so you need.
It's such an interesting space to be in, and we'll kind of, a few of the different cases I want to talk about today, I think that it shows like how diverse it is as a solution, and how, if you really want to support the entire solution end to end, it's a wide skill set. Because you're talking about, like, you may see one case where you're troubleshooting zone-based firewall, because if it's zone-based firewall issue, but it's on an SD-WAN router, well, it still comes to the SD-WAN team, because we understand how that feature is going to work within the SD-WAN solution. Whereas if you send it to a traditional, zone-based firewall engineer, they may not get all those nuances. And then, of course, it being an overlay type solution, we deal with IPsec a lot. So you get that aspect of security, but at the same time, well, vManage has a UI interface. And so, if the UI goes down, well, we have to troubleshoot that as well. And that's just, little drops in the bucket, because you're also still a network that you're troubleshooting, and where you're dealing, sometimes routing and switching problems. Well, not really as much switching, but routing is not uncommon. So it's a wide skill set. We've pulled people from routing, and they've done really well. VPN typically does really well. I definitely think I'm the only one to come from SP space, but I also, like I said, I was so early in my career. I think it was a really good, like, I learned how to take a case and how to talk to customers and stuff like that in a slower paced team. And then to come to SD-WAN, because it was, we had just acquired the solution, and it really took off fast.
And so for For the people who are not really well versed with the SD-WAN, like me, for instance, do you mind giving us a quick introduction on why it exists in the first place and what it does?
Yeah, absolutely. I'll do my best. As this is, I mean, it's been a journey for quite the last, I would say, 10, 15 years now, a little bit more actually, where customers are wanting to move away necessarily from some of that higher price traditional MPLS type networks. So SD-WAN fits into the solution here because you can choose your medium. Like a lot of customers still have some form of MPLS, but then they'll also have an internet provider where they can choose which traffic goes over which path, and you can kind of decrease your dependency on that MPLS higher cost networks. There's a lot of automation and all of that has come into this, which makes it easier for you to deploy. With vManage, you can deploy a template, or now we're moving into config groups in the last year or two to a couple hundred devices, and you're making sure that they've all got the same config. Nobody can go in, just log in on the CLI and make a random change that nobody documented that causes you, an issue at some point down the road. So there's a lot of different factors. I think one of the cool things I like is, just simple setup of a router. And SD-WAN, you don't have to have smart hands necessarily on site. As long as they can plug in a cable and you've got everything set up on the beforehand, you're good. Like you plug in a cable, it'll go out, get it. If you have DHCP, so that is the caveat. Like you have to have DHCP from your service provider or some type of server setup. You can get an IP address. It'll reach out to Cisco, go through your smart account and say, hey, where does this device belong? It'll give you the smart account. We call this the PMP process. We'll come back and say, hey, here's your SD-WAN vBON controller, and I'll kind of go through a little bit of what each controller does in just a minute. And that vBON says, well, hey, here's the other controllers in your network. It'll go to vManage and it'll pull the rest of your config. And that's a box. You just took the router out of the box and plugged it in. And like that, you've got it pulled down all of its config. You've just got to plug in cables and you're ready to go. If you can set it up so that it'll even upgrade the router if the router doesn't ship on a version you want. So like just something as simple as that, we've made the task so much simpler, I feel like, for customers when they're deploying routers. And even for RMAs, you can do something somewhat similar. So
it's more than just a plug and play protocol, right? Because you have all the provisioning part, also all the WAN connection management. That's also part of the solution. Is that correct?
Yeah. Yeah, I mean, you have policy. You can change how your network works as well. So you have policy you can put in place to not only steer your traffic, but to also structure how your network has its overlay formed. Some customers by traditional, just like out of the box default, it's automatically full mesh with everything, but they can get really crazy in large networks. And so you can put a policy in place that control how your tunnels form. Do you want to be in a hub and spoke? Do you want to, have some type of regional hub and spoke set up? And you really have a lot of granularity and control, which is nice. And since we're gonna talk about SD-WAN a little bit, I'm gonna go over the controllers a little bit because I tend to throw out the words because I know them, but just so everybody has an idea of what each controller does. So you have 3 different controllers, and you'll see them referred to a little bit differently in documentation because since the acquisition we changed the names, but I tend to use the old names because I feel like they're slightly less confusing, and they're what people are used to.
A stab at the marketing team, bam.
I've heard a lot of customer feedback to this effect, and that's where, well, I didn't like the names. I've also heard direct customer feedback that it's like, well, this is confusing. So your single pane of glass controller that has a UI is your vManage, and from there you can do a lot of monitoring. You can, set up those configurations. You can push out upgrades. It's going to do a lot of that kind of stuff for you. And it also has a bunch of architectural services built into it that are, make all of this happen. We'll talk maybe a little bit about a little bit of that, but it's so hard. I feel like if you don't understand the architecture, to understand a lot of different problems we can run into on that side of it, just because the architecture has also changed quite a bit in my tenure with the product. So it gets interesting.
So we have vManage management station for now, for me, in my language.
Exactly. And you'll see it manager is what the newer named. It was that's the least confusing of the 3 they renamed.
What about the others?
So the vBON or your validator is what they renamed it. It sounds like a superhero to me in the renaming, but it is your orchestration and kind of like your authenticator. So before you can join any SD-WAN overlay, like it's your gatekeeper. If VBON doesn't allow you through, then you can't join the overlay because it tells you about how to reach vManage. It tells you what your vSmart IP addresses are. So if you can't get to it, you're not going to do everything. It's really, hey, you're not in, or you're in.
That's the point of contact for onboarding.
Yes.
Okay.
And anytime, like if you something happened and control connections disconnect, then you'll also go back through VBON.
So that's the control plane, basically.
Yes.
Okay.
Yes. And the next one is your vSmart or controller. And this is the one I think they did the most interesting renaming, because we used to call them all controllers and now you're calling just one of them controllers. And it gets really confusing for customers because they're like, what do you mean they're all controllers? So it's vSmart in my mind, and I shall maintain that until they rename it in every piece of software in the product.
But what does it do if it doesn't manage and it doesn't act as onboarding?
So it is actually controlling all of your keys for IPsec, for your overlay tunnels and all of that. It pulls in all of the routing information, thinking of it like kind of like a route reflector. So it controls all of your policy that you're pushing out to devices. And for control policy specifically, so there's two different types of policies you can implement in SD-WAN. You have control policy, which affects how your network is going to run. Kind of like I mentioned, if you want to run hub and spoke, like you control what TLOC information, which is basically like, hey, this is the details. It's the details of how to reach this WAN interface. It controls which routers get that, so they can determine how to build tunnels in the overlay.
So you have two control plane, is that correct? Or one for security and one for onboarding?
So from a router's perspective, he's going to form control connections to VBON. And then from VBON, he gets information for vManage and vSmart. And then from vSmart, he'll get the information, hey, these are the other routers you need to connect to. This is the policy that's assigned to, your site ID and all of that. So you really have one control plane, but the vSmart is the one telling it, hey, this is what tunnels you need to form to. This is the policy and all of that. But it gets that over the control connection. You just form different tunnels to each of the controllers.
So vSmart has the architecture, right? Like knowing where to build tunnels with.
And all of the routes and all of that. It really does. Without vSmart, you can't have a traditional SD-WAN overlay without that, which is an interesting point. So you may have heard a little bit about SD routing, which is a newer concept in the last few years, which is basically you're doing pieces of SD-WAN, but they don't connect to vSmart. And it's a way that they're trying to have for customers to be able to migrate easier from traditional routing into an SD-WAN network. Well, hey, you can go ahead and get them, started on that path. You can go ahead and they'll talk to VBON. There's some different configuration there. And you can talk to vManage, get them on templates, get some of that monitoring in there. And then, at some point later, migrate them into the overlay with vSmart.
That reminds me of my network internship at a company where they said, your Cisco CCNA, here you go. We have 3 sites, we have firewalls, just do, site-to-site VPN and all that stuff. And then you have to manage each VPN tunnel. You had to in the past, each VPN tunnel separately. And then it's like, if we want to route some, you have 2 internet connections and you want to load balance, it was a disaster because then you need to play with ACLs and it's not granular at all. And then if, doing any routing and then security access list or whatever would also be a pain because everything is manual on each router, each firewall, etc. Now you're writing policies for all of that, right? So
yeah, exactly.
It can get complex, but at least you don't really deal with the low-level details anymore.
Well, and think about a hub router. Sometimes on these hub routers, you're forming 2,000 tunnels. If you had to manually configure all 2,000 tunnels, that's a pain. Whereas with this, literally you tell it, and vSmart takes care of telling you, hey, this is your tunnels. Like you can form, multiple different tunnels. Like if you've got, 2 or 3 different WAN interfaces on a router, you're forming tunnels with all of that. And it's so much more seamless.
But you're mentioning people migrating. So do we still have people that do not have SD anything and they manage everything? I mean, if you have 2, 3, 4 sites, sure. But what is the profile of those customers who are still migrating to SD-whatever? How many sites they have? Do you have people like, with insane amount of branches and they do everything manually still? in 2025?
I think so. Unfortunately, I think some of those customers are still out there because we still, I mean, it's we're still getting customers migrating in, not near at the same, I think, pace and scale as we were when I first joined the team. I think that's one interesting thing. I feel like I've grown somewhat with our customer base. Like I said, because I was a year out of college, and I had my CCNA, but I was still pretty green. And I remember some of my first early TAC calls because, like I said, there was three of us for at least my first like 6 months almost on the team. And I would take a case and I would talk, I'd get a basic problem description, and then I would literally be like, call a guy in the cube over, and I'm like, help, because like he had come from the startup. But that's how I learned. I would literally learn. He would sit beside me, and we would work through it together. I learned a lot just like sitting next to him and him walking me through how to solve some of these customers.
If there's one use case that I can think of might be helpful for our customers, that would be actually for service providers. For service providers, they are a huge network with so many connections to so many places. But I worked in service provider TAC for a long time, and I've never really heard about SD-WAN deployment for service providers. So did I miss anything, or is this not for service providers?
I think service providers is not something we see them as managed service providers generally. When I see an SP in my space, like it's because they're coming in and they're managing it for customers. We don't traditionally see them. I think the scale of an SP network is just a lot different. And I'm sure there's other reasons, but I think that's part of it. Because I mean, SD-WAN is scalable. Like we've got definitely customers, I think, with upwards of like 15,000 routers. In SD-WAN, but yeah, it's a lot. I was like, but that's definitely your far end. You also have decent number of customers who are 500 sites or so. So
It's
it
already a
varies.
lot, yeah.
Yeah, it is, but it's also like not to some degree. Like I've seen it, I guess, enough. Like once you get up above about 2,000, that's when you start to see, well, you've got to scale out your control plane a little bit more, and that's where you just really got to think about your scale and be a lot more intentional, I think, with your design when you get to that level, because you've got to think about, hey, do all of these tunnels really need to form everywhere, and be a little bit more, precious with your resources, especially from a hub router perspective.
Okay, so how about we dive in the first story? We have a small overview now. I'm sure we'll learn more about the technology. But...
Yeah, so I've seen a few different variations of this over the years, and you'll generally see it like right after customers start to migrate to SD-WAN. We'll get cases of, hey, this worked before, and this is what not working now, and it's always a great problem to start with is, hey guys, this was working before SD-WAN. And generally we'll see like some type of authentication. Sometimes it's for wireless clients, sometimes not, where they'll, trying to come in and suddenly they're not able to join the network. And, so we start troubleshooting, and we'll find, okay, well, you're starting with an authentication packet, maybe that's somewhere above 1,500 bytes to some degree. So maybe it's getting to the switch, and your MTU on the switch is set to 1,500 by default traditionally. And you would think also traditionally across a WAN that you're going to have a 1,500 byte MTU as well. But in SD-WAN, this is an overlay technology, so you have to think about your headers. So in SD-WAN, depending on what version and platform and all that combination, you're looking at either 58 or 62 bytes of IPsec header that you have to account for.
That was already the case back in the days of VPN, right? Like the VPN tunnel always had a lower MTU.
Yeah, but some customers are coming where they didn't have IPsec over the WAN. And so they weren't used to that, having that extra overhead, and now it's here. And so we get a packet, maybe on the SD-WAN router, and you've already fragmented a 1,500, an over 1,500 byte packet. So maybe you get, a packet that's, 100 bytes, and then you get a 1,500 packet. Well, we're having to fragment that again, that 1,500 byte packet, because it needs to go over the WAN transport. And so then you end up with a double fragmented packet. And some solutions just don't do well with that. I think typically, if you land just naturally on ice, in an SD-WAN overlay, you're fine. But, you have to think about all the things in the middle. Um, in specific, the case I was wanted to, talk about here, like I said, I've seen a few different variations, but I think this is one I've seen a little bit more frequently is like they'll have some type of load balancer in front of their ICE deployment or somewhere else in the path. And for some of those load balancers, if you have settings that can say, hey, well, I want to drop packets that are based on this size because they could be malicious and I don't want to allow that through. But we've seen that cause a number of issues, especially in these double fragmentation scenarios where, hey, you end up with a fairly small packet there once you've double fragmented.
So you have either, I think the issue is a very small packet, and then sometimes you have like a lot of fragments because it got fragmented over the SD-WAN, but then maybe there's another tunneling solution, another protocol, and it gets fragmented once more. And then you have a fragment that arrives before the main part of and the device doesn't handle reordering or is confused by having the third fragment than the first one and not the second or whatever. So the devices just don't like that too.
Yeah. And some of our older software too, especially like on like some of your, Catalyst switches like 2960s that are, not as much used nowadays. But some of those, depending on what software you were on, you actually weren't allowed to like lower the MTU past lower than 1500 too. So that's, you had to be very careful about where you could adjust this depending on a customer's network. Because like I said, some of those you couldn't lower the MTU. There's nothing you could do on that end, to make sure that from the SD-WAN perspective, you were getting a lower byte packet. So you could like, maybe tweak your load balancer and allow that traffic, or if sometimes, you could try to see if you could adjust something, I think one time we tried on a wireless LAN controller to see if we could lower the packet there. And I don't remember 100% what the result was. I was like, but we've seen a few different variations of this type of problem where it's just like, well, it's really not like crazy complicated, but it's just because you have to think about your MTU, over your whole infrastructure because you are going over a WAN and you have to think about both ends of it.
Especially that, like you mentioned, depending on the type of WAN connection that you have, you will have widely varying encapsulation sizes, like L2TP, PPOE, and all that. They all have widely different numbers. And working in that category, in that service provider before, I know that fragmentation is the source and the cause of all problem.
Well, and I think we don't see as many problems like this. Like I think nowadays, like if for customers deploying this nowadays, depending on what features they're going to use, I think it's sometimes not as big of a problem because we can we can do virtual fragment reassembly now. So like now on our Catalyst 8000 routers and SD-WAN, like you can turn that feature on. A year or two ago, I think, is when we first allowed that feature. I was like, so that's helping some customers with these type of problems too, is being able to use those type features.
Now I wonder how that works because I was going to say it sounds like an easy problem to fix, but it's easy if you do it with a computer because the CPU can store and think for a second. But typically our devices are hardware accelerated and the NPUs are going so fast, they cannot stop and pause and, oh, I have a fragment, who has the other one, and start negotiating between, because it has several cores in the NPU and they just have to process packets and they cannot really wait for each other, etc. So that's typically the excuse I heard, but okay, I didn't know about our Catalyst feature that does this. So now I wonder how that one works to go so quick and reassemble everything. So that's another episode.
Zone-based firewall and NAT already, you enable them, well, then they would actually wait for their fragments to be reassembled and then actually fragment them again for those features to work as designed to make sure you are handling everything already. So, and then from 20.12 or 17.12 release, we support it. Like you can just enable it first. I think it is a cool feature. It helps us a little bit, like I said, because now you're not taking packet captures all over the place trying to figure out where the fragment's happening, where you're losing it. Because it's really, that traditional, just like, well, hey, I have 3 fragments here and I see 2 here. Where the other one go, is how you're solving this type of problem.
So this is again one of those type of technologies where, despite the fact that you are focused on one aspect of the network, you still need to look end to end and inspect every single device in the path to figure out where the problem lies, right?
Yeah, no, a lot of times now it really depends. I think depending on the problem, I was like, we will because like sometimes it's like, well, hey, it's a straight up like throughput problem, well, if we know we're running just, we've got something connected directly on our, we call it service side or LAN side of our router, and then going over the WAN, we see it decreasing, then I'm not going to look out as much as like, but for these type of authentication problems, yeah, we'll look and say, hey, well, this is where, this is how it's coming into our network. Hey, how is it, how can we influence before it gets to us, or how can we influence like what's happening after us? Because like it traditionally like said it in the specific case where I was talking about, we've got like a 2960 over here, where you couldn't lower the MTU, and then you actually have we had an F5 load balancer in front of ICE that was dropping the packet because it was a certain byte lower than what they said, and they were able to just actually change that setting and allow that traffic, and that's how we end up solving the case. But like I said, the other thing is they were like, well, we have a 3560 and it doesn't have this problem. And they were on slightly different software. And so we figured out, well, on the 3562, you can lower the MTU setting. So depending on where customers were at was how you could adjust this and make it so that because SD-WAN, we caused the problem because you migrated to us and now you're fragmenting more. I was like, but it's also, we're just part of the transport.
Right, so you get blamed, I guess, by a lot of other technologies, right? Like, it was working fine, or baby wireless was working just fine. Then we had this amazing SD-WAN solution where we have load balancing and plenty of fancy features, and now the rest breaks.
We get blamed, like we used to. It's like, well, we're always the problem. We're always, we're always somewhere in the path, and so it's not an uncommon. Well, we migrated, especially, like I said, not that we don't see customers migrating now. It's just, you also have a lot of customers that already, have been with the solution for quite a number of times. Whereas in the early days, like it seemed like every case, well, we just migrated and that's how case problem descriptions started out.
In tech, we're used to cooperate, right? Because it's not necessarily the SD-WAN solution fault, but at least having SD-WAN troubleshooting to show which fragment is going where helps, the other technologies to pinpoint the problem.
Yeah.
Usually the pain point I see is on the customer side because people still work in different teams. And, usually the firewall guys are always blamed and they're always like, nah, it's not the firewall. And then plot twist, it's often still the firewall. But I think the best is to, you say, hey, I don't think, my solution is at fault here, but I'll help you troubleshoot your problem.
Yeah.
But a lot of companies, it doesn't really work like that. Like you have to really prove it would be an SD-WAN issue. And you're like, maybe it's not an SD-WAN issue, but I still need your help figuring out where my packets go because they're going all over the place.
Yeah, no, I think we do a good job of especially like I said, it's not uncommon. You come something into the WAN and especially like ours. Like sometimes we're like, look, it's clearly the service provider because this is how the packets arrive here, and we've got we'll take a fiat trace, which is basically we can tell, hey, this packet come in, it got encapsulated here. This is what path it way it went out, and we can't take a capture on the actual WAN side. Because it's always encrypted. And you can't tell anything really unless you can get creative and do some creative DSCP marking to mark specific traffic so you can, put something unique there and you can track that across, which is what we actually had to do quite frequently on the VH platforms because they don't have the same serviceability features that our Catalyst 8000 routers have, or even the ISR and ASRs have. And so a lot of times for those type of platforms, you didn't have packet traces and things like that. So if customers wanted to be able to prove that, the traffic was, traversing over the WAN, well, we put an ACL on the LAN side, mark the traffic with a specific DSCP bit because that gets carried to the IPsec header. And then we could take a capture on the WAN side on the other side of the SD-WAN tunnel and say, hey, well, we had 5 packets leave here with this DSCP bit and we've got 5 arrive here. So it's, it's not a WAN problem or something like that. But now with fiat trace, it's a lot easier because then you can just take a fiat trace and say, hey, well, I captured here and here, and this is where the packet arrives.
So the fiat trace is a capture inside the box, right? It tells you where inside the box the packet has been treated and where it got sent.
Yeah, and even for SD-WAN, it'll tell you, hey, well, this is, this is what policy it hits, this is what sequence it hit in that policy and all of that, which is really nice when you're troubleshooting, well, hey, customer, said, hey, I, was expecting this traffic to go over this WAN provider, but it was going over this. Can you help me figure out why? So those features are really helpful for us.
It's time for a next story.
I was gonna say we'll go through a quick, more UI focused one. I was like, and then we'll see how if we have some more time. I think this one's been a number of years since I worked it, but I remember the problem description came in is like they had pushed out a template change on vManage and had changed all of their interfaces from like auto negotiate to no auto negotiate. And they had some interfaces like get change status and like some BGPs were no shut. He's like, but we didn't mess with any of that config. And that was the problem description. Like they were pushing like an SNMP change to a bunch of routers and like, but we had all these weird things happen. And so I was like, okay, what templates were you changing? Getting all of those details. And I also started asking very specific. So you can have one template applied to a few hundred routers sometimes. So, well, how do you differentiate that? So in SD-WAN, you can have like things that are on by default. Or you can have things that are like going to be a general value. So that's going to apply to every single device that's applied to this template, or you can have device specific variables. So I started asking questions. I was like, okay, for these interface values for this BGP, are these device specific? Is this general? And it turns out they were all device specific variables that the customer was adjusting. And so now I'm like, okay, well, let me create this. And I finally figured out, like I was, okay, well, how can I apply? Because I was like, everything I'm doing, if I just run through the workflow traditionally, it was working fine. And then at one point I went back. And then I went back to, because before you push a config, like the process goes from an SD-WAN perspective is like, you say, hey, well, I've got this router. I want to attach it to this template. So you say attach, and then it says, okay, hey, I need you to fill out these device specific variables because I need you to tell me, what IP addresses need to be on what interfaces and what interface descriptions and, all of those things that are going to be very device specific. So you fill all of that in, and then you can go and actually preview the config before you push it out to the router. It'll tell you, hey, this is what you're changing. So this is what I read is on the router now, and this is where that piece that I mentioned earlier, where we use NSO in the vManage solution, is because it is how service providers use that. They keep track of configs and everything that are across their network. So it pulls the router's config and it says, hey, this is what you're planning to put to the router. And it'll, highlight all those really nice colors and everything. So it's easy to see what you're changing. And I was like, okay, all of this looks fine. Well, I was like, well, let me go back. And I was like, let me change this. And then when I went back, I was like, oh, everything that was supposed to be like no shut from an interface perspective suddenly was changed. And I was like, the simple act of like going back. So then it's like finding out with the customer, well, in the middle of your push, did you go back at all? And it seems like somewhere in the software we had made an error. It ended up being a bug where if you went back and previewed it, or from preview, if you went back at all, anything that was like a radio button or a checkbox like got unselected. So you could end up like, unchecking stuff that you never meet. And if you said, oh, I previewed before, I changed this one thing, and you didn't really look through your preview again, you'd miss it. Or, in like that case, customer was pushing, a bunch of different configurations to a couple hundred routers. They didn't go check every 101. They checked, maybe one or two, and maybe because they even had mentioned in their problem description, well, other routers had no issues. So maybe they just got lucky and checked all of the ones that didn't have an issue and didn't get something reverted.
Not taking the defense of anyone, but I could see how this would happen if you were a programmer and writing this code. Like, okay, going back, but not actually committing, going back, then doing another change. It's a tough task to keep track of what is the actual change that I need to do now. It's a bit like when in your editor you just do Ctrl-Z, 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 then redo and then undo again and then keep doing that. Yeah, that's crazy.
Yeah, and I can imagine like one solution would be to preview before pushing the config change, right? But if you're pushing a lot of devices, a human can anyway not validate everything you're pushing, right? It's just too many config.
Yeah, and like, hey, like I said, maybe I don't know what was going on in their change. Maybe they previewed everything and looked fine except for, hey, we need to change this one quick thing. So they went back, changed that, and I was like, oh, well, that's all I changed. Let me go ahead and go forth, and hey, it'll be fine. And well, it wasn't fine.
Thinking about programming, the solution to this kind of problem is having test cases and testing again afterwards. Is that what they were doing with NSO? You said they were checking their config, and were they afterwards double checking and spotting on which device the config was wrong and interfaces were shut when they were not supposed to?
I'm trying to remember how they actually found all of them. I know a lot of them, I mean, because you're changing the auto negotiate and stuff, they were actually having, routers that were having issues. So I think they were kind of chasing the problems all over the face, and they were really just relying on us mostly, like, hey, we know what happens, we know how to fix it, we know where, what needs to be here. Because one thing too is, like, you have a history on the router of what config was actually changed, that you can actually you can see from the CLI, which is really nicely. It's especially nice, I feel like, if you come from a traditional like iOS or iOXE background and you don't have that like config history like stored natively on the router. On SD-WAN, you can't lie to us. Like, literally, we have every record of config changes made, whether it was made by like through vManage or if you made it directly on the CLI, we can tell you when it was made, what was changed, all of that. So there's a solid record on the router.
Such a lifesaver.
It is beautiful. If we've got time for one
Sure.
more, I was
Let's
like,
go.
we can talk through one more. And like I said, I picked these stories a little bit intentionally because, like I said, I think it's important to share. Like, it's such a wide solution. As an engineer in this space, you have to know a lot. Like, already the two cases so far, like, they're different skill sets to some degree that you're using to troubleshoot those type of issues. So this next one I wanted to talk through is actually an IPsec problem. So now we're going into the security
Getting
space.
dirty.
So I'd been working with a financial customer of ours for a little bit. They were pretty highly escalated because they kept having issues where, like, they were saying, like the WAN transport would just stop and they would, reload or flap an interface, and then everything would come fine. But they were pretty much, they would get us either the logs, like, usually afterwards. Well, and it's so unhelpful from a WAN transport, because then I'm like, okay, well, I don't know what the state of tunnels were. I don't know what the state of counters were. Like, was anything increasing or anything like that? And so they would just get us data after the fact, and we had been working with them for a while, and we were like, hey, can we get like 5 minutes? Like, look, here's our numbers directly. Call us. Not even just, hey, go through TAC Frontline. Hey, here's our direct number. Like, guys, we want to help, but we've got to have some data to get further in this scenario. And so finally, this had been going on for a few months, and they weren't having outages every day, but every 3 or 4 weeks or so, they were having an issue. And it just seemed like, we'd get there and we'd get a little bit of data, but we weren't. And we had seen some counters that we thought were, an issue, some IPsec counters, but we're like, hey, we know that this is a high number. We don't expect this number to be this high, but we also can't tell you 100% that this is what it was, because we don't know what was incrementing at the time. Like, we feel like this is a high number. It's concerning to us. I think we even said, hey, we know we have a few bugs here, that might, cause this drop if you, depending on your availability. So I think they even upgraded, because they weren't willing to, give us, an outage time. They're just like, hey, well, we'd rather upgrade and, see if it'll maybe go away. Well, it didn't. Then we're like, hey guys, like, we're really going to need to be able to troubleshoot this. We're going to need to be able to understand exactly why the routers are getting in this state. So if they finally got us on, I think we had maybe 5-10 minutes, and they're like, because guys, you're affecting trading, you're affecting our revenue stream. And so we're like, okay. So we grabbed every single command like we could think of between the two routers, because you had a traditional like the Edge router, which is the ones that came through the acquisition. And then you had on the other side, I think a Calus 8500 or something like that, one of the Calus 8K routers. And so we were finally able to see that, hey, those integrity drops that, we had seen from an IPsec perspective were in fact incrementing at the time of the issue. We saw that on the call, and we could even see that there were like authentication failures on the particular tunnel that they were telling us was impacted. And so like, okay, we're on the right go. And we like I said, we grabbed everything we could in. And what we noticed is we grabbed the sequence numbers on both sides. And what we noticed is that the sequence numbers on one side, on the V-edge side, were set to 0. And on the C-edge side or the Callus AK side, it was set over 5 billion. So like, okay, obviously something here happened. Now it's just figuring out what. And we could also see that at some point, before they started reporting issues, that there had been a lot of control connections flapping, and all of that. So we're like, okay, we're getting somewhere with this. We've got a likely trigger here, because we had seen pretty much in all the other scenarios they reported that, hey, at some point before this there was a rekey or control flapped, all of that. So we're like, okay, we've got a trigger here. So we go into the lab, get routers, and we're like, all right, let's see what we can do. So we started pumping traffic through, and we're flapping interfaces trying to get it, and we're not getting anywhere. So we started talking to the developer, and he's like, well, hey, on these routers, we have a rollover point. So traditionally in ESP, you'll have 32 bits that have your sequence number, but we actually have a rollover point, and we'll roll over to 64. He's like, so this one side, he's like, that 5 billion is over the rollover point.
Yeah.
He's like, these platforms handle this differently. So we're like, okay, now we've really got somewhere. I think it's the one time where it's like we were at that, after talking to the developer, we were like, we know exactly how to get this reproduced. Like, we just need to get this over the rollover point, and let's just start flapping things and see what happens. And so that's literally what we did. We pushed enough traffic to get it over the rollover point and flap the interface in the middle. Not even traditionally on the routers, just like something in the path. We flapped an interface, brought it back, and we had recreated it. Like, we started seeing all of this drops. And it was literally the routers handled the rollover point a little bit differently between the two softwares, because you are like the Viptela routers, the V-edge routers, they use Viptela OS. It's a completely different operating system than your iOS XE that you have, and even the iOS XE that we run is slightly different than traditional iOS XE, because we go into controller mode on those routers. But even still, we handle that in a completely different way. And so I think it was so cool, because like once we got those little bit of information from the developer, we were like, we're going to reproduce this. We know exactly how to do it. And that was a cool feeling, I feel like, because you were just like, all right, we just got, then it's just a waiting game, because like getting the counters up that high so that we could actually flap it. Like, I think we started it like in the middle of the afternoon, and then we logged on at like 8 or 9 o'clock that night. Like, all right, is it there yet? Can we flap the interface yet? Because we were just trying to push as much traffic through as we could so we could get the sequence number above that place. Because on the iOS 6e side, they can artificially like set it, and they'll do that during testing so they can get it that high and they don't have to wait to put traffic. But on the V-edge side, we didn't have any of those type of mechanisms, and that's where we're like, we just have to push traffic until we can get it there. And flap it. I ended up reproducing that bug a few different times. I found it in a few different scenarios where we could hit it.
I can feel the joy of figuring out what you need to do to reproduce, and then finally being able to reproduce. Because when the customers ask us, can you reproduce? And we have no idea where to start, because you're like, I'm taking 2 routers, I'm passing traffic, and obviously I'm not facing any issue. Just like thousands of other Cisco customers who are not having your issue. Like, if I don't know where to start to reproduce, like...
Exactly. Well, and it's like, and I can go in, I can flap interfaces, but until you get it, until you got above that threshold, you weren't gonna get there. And I think the other thing that plays a factor here is like, so if you were with traditional, if you had the default settings for your rekey values and all of that, what was unlikely you were actually ever going to get to that number to even hit this. So that's the reason we hadn't seen it, just everywhere, because the WAN's not always the most stable. But like if you had, by default, your rekey value is 24 hours. So if a lot of customers aren't putting out, 5 billion, or 4 billion, whatever the 4 billion and whatever, however many packets it is, they're not always getting to that sequence number to even experience this. But if you had set it to 7 days. I think they had it set to 7 days or something like that. And so they were pushing enough traffic, and it just the interface flapped when they were above that time. They'd hit it. So it took us several months of working with them, and part of it, like I said, because they'd have an outage, and we'd get one more little piece of the puzzle. But it took us, I think, 5-6 months of working with them before we could ever actually get from their first hey, we had an outage, we need to know what happened. Because there's all these mixed up details in the middle. Oh, OSPF was affected this time, but not this stuff, and all this too. And in these type of issues, depending on where it was, because we use queuing, and so this could also affect specific traffic. Sometimes it might have affected, depending on where the sequence number went high and was above that value, it could have impacted Q0 traffic, so all of your control traffic, or it may have impacted more of your data plane traffic, depending on what you were doing and how your QoS was set in place. Because that's one thing we looked at in the middle of this. We were like, hey, so we did know, we got some just straight up captures, because we were just trying to figure out hey, is, our sequence numbers just getting off enough, because you've got, QoS and the provider is just way off, and you've got packets, coming in way out of order. And we had seen a little bit of out of order there, and we're like, hey, there's definitely some things you guys could do to optimize this. And so that, you're matching the same QoS settings and what your provider is going to do. And so how your traffic's handled better. So those are some things, we had tried to help them put in place in the middle of this. Hey, here's some things you can do to optimize this. But like I said, ultimately, they were just getting up above a sequence number, and any type of flap then could trigger their issue.
Great job. That was cool. I know with hindsight, it sounds easy now that we know it, right? But I imagine the whole research from Cisco, from the customer into this to figure out that it was indeed the problem. Because like we were just discussing before, when you get started with it, you don't know really what it could be. And it could really be anything, a counter, a bug, and something crazy.
Exactly.
So, yeah.
No, cool. I think it's one of those, I nerded out so hard, because it's also explaining that rollover point is not something we always have to think about a whole lot. Just because if it works, great. And you don't, but explaining that, I nerded out so hard explaining it to everybody. And I was like, I lost so many people. So I tried in explaining this, I tried so hard to explain it really clearly. And I love that we've handled this better today. And we've added some extra, bits to the header that we include. And that's how we're handling this a little bit better today between the platforms, or I say a little bit better. We are handling it today, so that you actually pass that and don't, flap it and, oh, well, one side knew about it, one side didn't, it'll reset to 0.
Thanks, Kendra. That was super nice. I love all the stories that you told us. I learned a lot.
That was super interesting. Thank you. Thanks for listening to this episode of the Cisco Tech Stories podcast. You can subscribe to us on the Cisco Podcast Network in SoundCloud or your favorite podcasting app. You can also find us on our own channel called Cisco Tech Stories in every podcasting application. We are also on X at Cisco Tech Story without the S, and on Instagram and YouTube at Cisco Tech Stories. Thanks, and see you next month.
Wires and waves, the world in sight. Every branch, a shining light. Packets fly, the speed is real. SD-WAN, the power we feel. Oh yeah! Oh yeah! Every site, one by one, linked together. Now we're done. Connected. Across the grid. Every byte, every bit, we did secure and strong. We stand as one. SD-WAN, the future's begun. Backbone strong, enterprise-wide. Data flows, a seamless ride. Cloud to cloud, we're breaking through. SD-WAN, we depend on you. Every site, one by one, linked together. Now we're done. Connected. Across the grid. Every byte, every bit, we did secure and strong. We stand as one. SD-WAN, the future's begun. You are